All right, so in the world of big data, you've probably heard of two big names that are always in the ring, Lambda and Kappa. In this explainer, we're going to break down exactly how they work, what they're really for, and most importantly, how you can figure out which one is right for you. If you want to get your head around how modern companies handle just massive amounts of data, you are absolutely in the right place.
So, let's start with the central problem that pretty much every modern business faces. How on earth do you analyze decades of historical data to get those super accurate reports while also reacting to what's happening this very second? It's this classic tug-of-war, you know? You've got accuracy on one side and speed on the other.
And that right there is the core challenge. We've got data exploding from every direction. Think IoT devices, mobile apps, AI systems. The old way of doing things just completely broke down. You know those traditional systems that were built for slow, overnight batch processing? They just couldn't keep up. That tension is exactly what forced the creation of the architectures we're about to dive into.
Okay, so here's our game plan. First, we'll really frame the problem. Then, we're going to break down the Lambda and Kappa architectures one by one. After that, we'll put them head-to-head in a direct comparison and wrap up with how you can decide which path is right for your data's future. Let's get into it.
So first up, let's really set the stage. Why did we even need to move beyond simple batch processing in the first place? What changed?
Well, think about it like this. The old way, batch processing, was totally fine for running reports overnight on yesterday's sales data. But today, a business needs to know what a customer is doing on their website this second. They need both that deep, historical view and those immediate, real-time insights just to stay in the game.
And that dilemma brings us right to our first major solution, the Lambda Architecture, which was specifically designed to give you the best of both worlds.
At its heart, Lambda is a hybrid. It basically says, hey, why choose? Let's just do both. It creates two parallel paths for your data, one that's slow but incredibly comprehensive, and another that's just lightning fast for those immediate results.
So how does this whole thing actually work? Well, it all kicks off with data ingestion. Just picture a giant funnel where all your raw data, from apps, logs, sensors, you name it, pours right in. From that single point, the data gets sent down two very, very different paths. The moment that data comes in, it's split. One copy goes down the batch layer. Now this is the slow and steady path. The data gets stored for the long haul, usually in a data lake, and it's processed in these huge chunks to create a totally comprehensive and perfectly accurate historical record. At the exact same time, the other copy just flies through the speed layer, which is all about one thing, pure velocity. It processes data instantly to give you a real-time view. Then a clever serving layer combines the results from both paths, so when you ask a question, you get the complete up-to-the-second picture. And this brings us to the big trade-off with Lambda. On the plus side, it's incredibly powerful. You get that perfect mix of deep historical accuracy and immediate speed. It's super fault-tolerant, too. But the big con? It's complexity. I mean, you are literally building and maintaining two separate data processing systems. That means double the code bases, higher operational costs, and frankly, a much bigger headache for your engineering team.
That very complexity is what led to the next step in the evolution. People started asking, what if we could simplify all of this? And that's exactly where the Kappa architecture comes into the picture.
The philosophy behind Kappa is just radically simple. It looks at the complexity of Lambda and asks a really powerful question. What if batch processing isn't a separate thing at all? What if it's just a special case of stream processing? The core idea here is to treat everything as a single, continuous stream of events, whether that event happened a year ago or just a millisecond ago.
And the data flow totally reflects this beautiful simplicity. Everything comes in as one continuous stream, it gets processed by a single engine, and the results are served up for you to query. There's no separate batch layer at all. So if you need to fix a mistake or recalculate history, you just go back to the beginning of your data log and replay the stream through your new logic. It's a really elegant and unified approach.
So you can see how Kappa's advantages are a direct answer to Lambda's biggest problems. It's way simpler, you've only got one code base to maintain, which makes it perfect for real-time applications like live machine learning or fraud detection. But, and it's a big but, there's a catch. Reprocessing years of history, billions of events, can be super expensive and slow. And it might not have the raw horsepower for some of those really heavy traditional business intelligence reports.
All right, now that we know both of the contenders, let's put them side by side and see how they really stack up against each other.
So let's just break down the key differences here. Lambda, you've got two layers, batch and streaming. Kappa has just one, only streaming.
Right away, that tells you Lambda is going to be more complex and almost certainly more expensive to run. The choice really comes down to your workload. Lambda is built for those hybrid scenarios where you need both deep history and real-time speed. Kappa, on the other hand, just shines in purely real-time use cases, like with IoT data or live AI models.
Let's just double-click on this point for a second, because honestly, for a lot of companies, this is the deciding factor. The operational overhead of managing two completely distinct pipelines in Lambda is huge. Kappa's single, unified pipeline makes everything, development, deployment, and maintenance, so much leaner.
And you can see how this all plays out in the real world. A bank, for instance, might use Lambda because it needs that real-time fraud detection, but it also needs those rock-solid historical reports for compliance. On the flip side, an e-commerce site is probably going to go with Kappa to power its real-time product recommendations. It is all about matching the architecture to the specific business need.
So this brings us to the final, and let's be real, the most important question. How do you actually choose the right path for your organization's data?
Okay, let's play out a scenario. Imagine your #1 priority is supporting a business intelligence team. They're running these incredibly complex queries over years of historical data, and every single number in their reports has to be perfectly validated and auditable.
In that case, yeah, Lambda is your safe bet. That dedicated batch layer is tailor-made for this exact kind of heavy, historical, high-accuracy workload. It's proven, it's reliable, and it's built for those enterprise needs.
But what if you're on the complete other end of the spectrum? Let's say you're a startup. Your main product involves processing data from thousands of IoT sensors to predict maintenance issues, and you have to do it all without breaking the bank. Then Kappa is almost certainly your best move. Its simplicity, its lower cost, and its intense focus on real-time just make it the ideal architecture for modern, event-driven apps and for teams that really need to move fast.
So, to wrap all this up, let's leave you with one final thought. We spent this whole time framing this as a choice, right? Lambda times Kappa. But what if that choice itself is starting to become obsolete? New data platforms are beginning to merge batch and streaming into one unified system, giving you the best of both worlds without all the complexity. So the real question for the future might not be which architecture to choose, but whether we'll even need to make that choice at all. Thanks for diving into this with us.